In this video, I'm going to show you how to find the mean, median, mode, and range of a set of data. Mean, median, and mode are called measures of central tendency because they are all ways to approximate the center of a set of data, whereas range will try to approximate how wide your data set is. I'm going to start with explaining the mean, and the mean is more often called the average of a set of data, and the mean or the average is the leveling out of data. So basically what that means is that if I have a set of numbers, I can shift around parts of those numbers until each one of the numbers has the same value, and that value is called the mean or the average of the data. So let me show you what that would look like with a data set. And we can think of these numbers that I'm going to write down as maybe assignment scores. So let's say that this person had an assignment score of a 100, a 90, a 60, another 90, and another 60. To find the mean or the average, I want to level out this data, and I'm going to do that by shifting around 10 points at a time until I get a leveling out point. So I'm going to start with this 100, and I'm going to take 10 points away, but I'm going to add that 10 points back to a low assignment and give it those 10 points so it becomes a 70. I'm going to continue doing that. I'm going to do that to this 90, take 10 points away and give it to this 60. It becomes a 70. I'm going to take 10 points away from this 90 and give it to this 70. And then I'm going to take 10 points away from this 90 and also give it to this 70. I have now leveled out my data. Each of my data scores has now become an 80. So the mean or average of my data is 80. I want to show you another example of finding mean, and this time I'm going to use a bunch of things that I'm going to call towers. So if we think of these as individual towers, I have a tower here that is 5 stories tall. I have a tower here that is 8 stories tall, and so on all the way across. I have a total of 6 towers here, and I'm going to try to level out these towers. I can follow the same procedure that I did in the last example by shifting my data around. So I can take, for example, a block off of this top tower here, basically the top story of that one, and add it to one of my shorter towers. So I'm going to move it to right there, and then continue that process, taking one off of one of the taller towers and putting it onto one of the shorter towers until eventually my towers all are the same amount of stories high. So it looks like I've now leveled them all out. And if I look back at each of the towers now, each tower has 1, 2, 3, 4, 5, 6 stories in it. So I could say the mean or the average height of each tower is 6. However, this is not a very practical way for finding the mean because it takes a long time, and especially if I have a large set of data, it would be a very inefficient way and impractical way to go about finding the leveling out point. So let me undo what I just did and put back the original towers. So I'm going to delete them and then put them back. And now that I have my original towers back, what I can do is I know that I have 6 towers, and I can go through and I can combine all of the stories from each tower into one big long chain. So I'm going to take this first tower and combine it with my second tower, and I may have to shrink this a little bit so you can see it on the screen. And then I'm going to take my next tower and move it to the bottom of this one, and I'm going to continue that until I have all of my towers combined into one big tall tower. Let me shrink this one more time so I can still see everything, and then move these last 2 towers underneath. Now I have basically a super tower that is 36 stories high, and I'm now wanting to break this tower back apart to create 6 equally high towers. So I'm going to take my big super tower and break it apart into equal towers. and they each have a height of 6 stories. Hopefully you noticed that what I really just did there is I took 36 total stories and I split it into 6 equal groups, and that gave me a total of 6 stories in each group. So if I go back to my original tower again, I can show you a shortcut. So here's my original towers, and in the first tower here I had 5. This one I had 8 stories, 3, 9, 4, and then 7. If I would have, what I really just did when I made that big super tower is I combined each of these. I added up each of these values, each of these, the heights of my towers, and I got a total height of 36 stories. But then I wanted to split it up in a different way so that my heights were equally. I knew that I had a total of 6 towers that I needed to share it with, so all I did was do division, and I took my 36, I shared it equally with 6 towers. I got 6 stories in each one. So to find the mean of a set of data, the easiest way to do that is to combine all of your data and then split it into equal groups based on how many original data points that you had. So find the sum of your data and then divide by how many pieces of data that you had. To recap so far, there are 3 measures of central tendency. One of them is the mean or the average, which is the leveling out point of data. I'm going to show you 2 others. The first one is the median, which is the middle point of data. And the next one is the mode. And the mode of data is the number that occurs most frequently in your data set. Each of these measures of central tendency are trying to describe the center of your data set. So here is a graph. This graph shows the number of siblings in, let's say, a classroom of 25 students. So each student is represented by an X, and each student then basically went up to the board and they put an X on the graph next to the number of siblings that they have. We can use mean, median, and mode to try to describe the center of this graph. I'm going to start with the mode because that's the easiest to find in a set of data. Remember that the mode is the most frequently occurring number in your data. So the most common number of siblings that students have is 1, because we have 1, 2, 3, 4, 5, 6, 7, 8 students who have 1 sibling, and only 1, 2, 3, 4, 5, 6, 7 who have 2 siblings, and everything else is fewer than that. The mode of the data is then 1 sibling. The median is the middle point of the set of data, and when I already have my data arranged on a graph like this, I can find the median by pairing up the largest piece of data with the smallest piece of data and then removing those two, and eventually I will narrow it down to the middle of my set of data. So I'm going to do that by marking out the person who said they have 7 siblings with one of the people who said they have none, and then a person with 4 siblings with also an only child there, and another one with 4 with an only child. And I'm going to keep going and mark out the biggest piece of data and the smallest piece of data until I find out what the middle piece of data would be. And I can see now that my middle piece of data is right here, which happens to be 2 siblings. This tells me that half the students in the class had either 2 siblings or more, and half the students in the class had 2 siblings or fewer. If your data is not already neatly arranged in a graph like this, then you'll have to do what I just did out to the side. You'll have to rewrite all of your data and put it in order. And I put it in order from least to greatest. You could either put it in order from least to greatest or greatest to least, but you have to arrange it so that it's easy to mark out the largest and the smallest number and then keep going over and over again until eventually you end up with the middle piece of data. So I'm going to keep doing this, marking out big and small, pairing them up. And I can see that this 2 right here is the median, the middle piece of data, because half of the data is larger and half of the data is smaller. And lastly, if I want to find out the mean or the average number of siblings in this class, I'm going to combine all of the number of siblings, and then I'm going to divide that among 25 students, because there were 25 students who took this survey. So right here, these 3 are nothing. And then right here, I have 8 students who said that they had 1. So if I add all of those ones up, that would be 8. Right here, I have 2, 4, 6, 8, 10, 12, 14 siblings total. And then right here, I have 3, 6, 9, 12 siblings. Right here, I have 4, 8. And then lastly, right here, I have 7. Let me combine each of these, and I have, 22 there. And this is 27. 22 and 27 gives me a total of 49 siblings in the class. Siblings of students in the class. But I want to know what is the mean or average number of siblings per student. So I have to take those total of 49 and I have to level them out among 25 students. So to do that, I'm going to divide by 25. 25 goes into 49 one time, and then there would be 25 leftovers. So my mean or my average is 1 24/25, which is very close to 2 wholes. So that means that the average number of siblings that a student has in this class is nearly 2 siblings. As a matter of fact, if I wanted to change that to a decimal, it would be 1 9600. 1.96 siblings per student. Remember that each of these measures of central tendency is trying to describe the center of our data. So you'll notice that the mean and the median are actually very close to each other. The mode is slightly different because remember, the mode is only paying attention to what was the most common piece of data. The mean is paying attention to every piece of data, including the 7, which is called an outlier because it's way larger than all the other pieces of data. And the median is just looking for what is the middle point where half the data is larger and half the data is smaller. In this example, we have somebody who logged their time spent in minutes per day, bike riding versus reading. So we can find the mean, median, and mode of this data and then compare those for bike riding versus reading. I'm going to start with the mode, the most common piece of data. And it looks like for bike riding, the most common amount of time spent bike riding is 20 because I see 3 20s. So that would be 20 minutes. And the mode for reading, the most common piece of data again is also 20 because I see 3 20s and only 2 40s there. So it's going to be 20 minutes as well. To find the median, I've put all of my data in order from least to greatest. So I can start with bike riding and pair up the smallest amount of time with the largest, and I can keep going. And then this right here is my median amount of minutes. So the median amount of minutes was again 20 minutes. Could do the same thing for reading. Pair up the smallest with the largest. And the median number of minutes in this case was 30 minutes. Lastly, for the mean, I want to combine all of the number of minutes for bike riding and then average them out among the 7 days, level them out among the 7 days, and then do the same thing for reading. When I add these up, I have 20 plus nothing, that's 20, plus 40 more is 60, plus 20 more is 80, 20 more is 100, 80 more is 180, and then 60 more is 240 total minutes. So if I have 240 minutes that I spent bike riding, I want to divide that equally among 7 days. And I can do some division right here. 7 goes into 30 4 times. So it looks like I have 34 2/7 minutes. So a little bit less than 34.5 minutes. For reading, I have 30 plus 20, that's 50. Plus 20 more, that's 70. Plus 40 more is 110. 20 more than that is 130. 40 more than that is 170, and 80 more than that is 250. Now I'm going to take 250 and level it out among 7 days. And when I do that, I get 35 minutes with 5 leftovers, so 35 and 5/7 minutes. So it looks like when we look at the mean and the median, it tells us that we spent a little bit more time reading than bike riding. On a typical day, though, the most common amount of time that we spent bike riding and reading was 20 minutes. There's one other data landmark that I'm going to show you in this video, and that's called the range of data. And it is not a measure of central tendency, but it does answer the question, how far apart are the maximum and minimum of your set of data. So let's now look at an example that will put all of these data landmarks together. And in this example, we have 2 teams of basketball players. Team 1 is the white team, team 2 is the green team, and we're comparing their height. And this data has it listed in feet and inches, and then also just in inches. I'm just going to look at just the inches for this because that'll be easier for us to do subtraction and division with. But when we're looking at the feet and inches, that's more of what we typically look at in the United States. So that kind of will help you translate this data into numbers that are more meaningful to you. So let's start with our measures of central tendency, and I'm going to begin with the mode again. So if I look at team 1, the most common height that I see is 76 inches. So that is my mode. And team 2, the green team, most common height is again 76 inches. The mode is the same. The median is the middle height, and these numbers are already in order for each team, so I can just mark out the biggest and the smallest, and the median for team 1 is 76 inches. Team 2, biggest, smallest, median for team 2 is also 76 inches. The mean or the average is going to require me to do a little bit of calculation. I need to combine the heights for everybody on each of the teams. So I'm going to combine team 1 out to the side here. So I have 2 and 3, that's 5, 6 and 6 is 12, 12 and 8 is 20, that 20 and 5 is 25, carry the 2. 5 sevens is 35 and 2 is 37. So if I take that 375 total height, if I stacked all the players on top of each other and then divided by the 5 people on the teams, I'd find out that we have a mean or an average height of 75 inches for team 1. For team 2, I'm going to do the same thing, stack up all of their heights and combine them. Okay, so I have a 6 and a 4, that's 10. I have a 6 and a 2, that's 8, so that's 18. 18 and 7 is 25. 8 and a 2 is 10. 3 sevens is 21, so that's 31, and 6 is 37. And it looks like I have 375 here, so when I divide that out, I'm going to get exactly the same thing, a mean or an average height of 75 inches. So even though my players on each team are all different heights, when we're looking at measure of central tendency, my measures of central tendency for team 1 and 2 are identical. And that's why in this example, the measure of central tendency doesn't tell the whole story about our data. This is where we need to pull in the range to be able to see a more complete picture. Remember that the range is how far apart the maximum and the minimum pieces of data are. I can find that by subtracting. So the range is 6 inches for the white team. And for the green team, when I subtract the maximum and minimum, I get 17 inches. Here's a zoomed in view of the maximum minimum players on each team. So if we look at the white team, the shortest player and the tallest player are only 6 inches apart in height, so they actually don't look all that much different. Whereas on the green team, if you look at that player who's 7 feet tall compared to the player who's 5'7", that shortest player barely comes up to that tallest player's shoulder. So even though the measures of central tendency for both teams were identical, we really need all four pieces of all four of our data landmarks to give us the full picture of a set of data. In this case, the range helps us understand that the green team has more of a variety of heights on the team.